in today's adventure we are looking at this unit, or this board, came from the southern parts of Zululand. It's from an Ecoray high tension generator as used in medical X-ray units. So let's see what's happening. The complaint is the machine doesn't switch on properly. I've connected power cable from the 220 output of the variable transformer to the 220 input. However, at around 80 volts or so, this should power up and that light there should come on and stay on. So let's crank up the voltage and see what happens. It flashed once, then went off again. If you look there, let's see. Nothing. So clearly it's not powering up. I can hear a slight whine also when I do boot it up. There you can see it just flashes once. So let's see where the trouble starts. So of course we've got our oscilloscope meter, and for the record, these were not sponsored. I had to buy them myself, but they're awesome tools. So my toolkit actually includes one of those and the DPO X180H. Awesome piece of machinery. This is a phosphor simulation scope, and this is an everyday basic scope meter. It's got functions for oscilloscope and multimeter and signal generator and all weird wonderful things in between. In this case we'll use the oscilloscope mode. The oscilloscope is just a glorified multimeter. Most of you know multimeters as these things that will just give you a reading. The difference between this and this is this unit will actually draw you a picture of what's happening. So it will take a reading after a second and make a dot. A reading after another second, make another, then you'll join the dots, and then you see what happens with the voltage over time, which tells us a lot more than what this other unit will do. Let's connect the oscilloscope and see what happens. I'm going to switch off channel 2. Oh, channel 2 is there. Channel 2. Oh, come on. Channel 2 off. There we go. Only need one channel. Okay, so on the oscilloscope, once you turn it on, you can select between oscilloscope and meter mode. In this case we'll use oscilloscope mode so that we can get a picture of what's happening inside the machine. Once you select oscilloscope, we can now go and press and hold the auto button on this unit, and it will run the calibration sequence. Always make sure that there's nothing connected to the scope when you run the calibration, otherwise it will calibrate bad data into the unit. Let's wait for it to complete. So while that's doing its thing, let's explain the oscilloscope. So what the oscilloscope will do, it's like an old-fashioned line graph used to do at school. So after a time it will take a voltage reading and draw a line. After another time it will do another reading, and then it will take lots of these readings one after the other, and it will draw a line for us so we can see what's happening with our voltage. So that is an oscilloscope. A normal multimeter, as we know it, like this, only takes a single reading and displays it, so you cannot see if something is changing. So we've got the oscilloscope there. Let's get channel 2. Let's turn it off again. Connect our oscilloscope to channel 1, like that. Now we can see some is already filled with this board. These have been changed. So I'm going to start with that and start look for the problem at the last place somebody else worked on it. That's usually where we start. There. So I'm going to connect my ground to this point here, and the power signal to that capacitor there, which actually ends up going to this unit, this chip here. So let's see what happens when we power it up. There's no pause for stupidity. If there were, I would have needed a lot of those. So I've got channel 1 selected, 1 times probe, and we're looking for a DC signal. So DC times 1. Awesome. Let's move it to the center. And since we're expecting to see a 5-volt signal there, I'm going to change my scale for this to 2 volts per division, so I can get 3 divisions. Repeat our test from previously. So if you look at this, you will see there are some artifacts on the waveform. Instead of a straight line, we get, let me see if I can catch one for you. I'm going to move it down so I can get the bigger waveform. And then this is my trigger, and move it to there so that it will catch those units for you, those little sparks. And there you can see it there, a teeny weeny spark. So this cap isn't filtering properly. Let's move it down to move this down to the 0. We've got 1 volt selected, so it's 1, 2, 3, got about 3.5 volts on that signal, and we're expecting around 5 volts on there, as that's our 5 volt line. Let's double check on the 5 volt signal. I'm going to remove this and double check there on the 5 volt check pin and pause. Oh wow, even that's giving us dodgy values. 1.5 volts. So clearly this power supply isn't booting up as it's supposed to. So I'm going to start by replacing those silly things with the correct ones, and then we'll take it from there. Okay guys, so I've replaced the two capacitors. I'm going to crank it up again. Although this board is rated for 220 volts, it will actually switch on anything above about 86 volts or so because of the switch mode power supplies that's incorporated. So there's my oscilloscope ready again. Let's see if we crank it up. Now we're on 60, there we go. And the power is up. You can see the lights constantly on now, and you'll see there red lights flashing. The CPU is trying to communicate to the rest of the system. So let's minimize this. There we can see we put a proper ripple now instead of the spikes we were seeing earlier. It's 246 volts, only about 7.5 volts on this unit. So let's crank it up just a little bit more to 7.5. Let's go to so let's look for our amperage reading. Here we go. And I'm going to remove frequency. I don't need frequency. And just Vmax just for fun. So RMS is 7.25 volts, our max is 8.06. Okay, so nothing heating up, that's nice and cool. That's still on. The CPU is trying to communicate, and we are ready to roll.